Hi everyone, this is your struggling CS student, and today let's solve another LeetCode problem of the day. Today's problem 2048 next greater numerically balanced number. So an integer x is numerically balanced if for every digit in the number x there are exactly d occurrences of that digit in x. Given an integer, return the smallest numerically balanced number that is strictly greater than n. Okay, I'm not sure what that means yet. Let's take a look at some examples. Okay, let's see. An integer x is numerically balanced. For every digit d in the number x, there are exactly d occurrences of that digit in x. Okay, so if let's say the integer is 1, and for every digit d in the number 1, there are exactly 1 occurrences of that digit in 1, then 1 is numerically balanced. And in this case, wait, what? So given an integer n, return the smallest numerically balanced number that's strictly greater than n. I see, okay. So because we want the next numerically balanced number that is strictly greater than 1, then in that case, the next best candidate is 22. And the smallest numerically balanced. Let's see this one. Okay. I see, okay. So just to make sure my understanding is correct, I'm gonna do a sample test case. With a sample test case of 0, I should get 1, right? Yeah. Okay, so now at least we know the problem, understand some of the examples as well. So in this case, is how do we iterate or get the next best candidate in sort of like a greedy manner? For example, I guess in this case, because the number has to be strictly greater than 1000, we can try like, okay, what about 122? Obviously 122 is not going to work. So the next best candidate will be 1333. What about this one? Hmm. What are the constraints? 10 to the power of 6. Maybe we can brute force this. As in like we can just check every possibility. Is that even possible? What I mean by that is like, because it's only up to 10 to the power 6, so you have 10 to the power 1, 2, 3, 4, 5, 6. How many possibilities are there? 1, 2, 3, 4, 5, 6, 7. There's only 7 digits. But for each digit, how many possibilities are there? There are like 0 to 9. So that will be, because it's 1, 2, 3, 4, 5, 6, 7 digits. So that will be 7 to the power 9 possibilities, I think. 7 to the power 9, if we brute force it, that number seems to be very huge. Calculator. 7 to the power of 9. I 7 to the power of 9. Okay, that is too big. 40 million? Holy moly. That is definitely too big. Wait, 40 million? Is that too big? 7 to what? To the power of 9. That is 40 million. Can we just brute force this? 40 million. I think we can. I think we can brute force this because like well, this is like a LeetCode specific thing, but like the worst or the maximum number of operations that you can perform is actually 100 million. So we can also like do early termination, right? can do early termination, for example, at a particular number x. We can check if like if x is less than if x is less than the if x is less than or equals to the origin number n, we just move on somehow. That this will be like a this will be a backtracking solution. Honestly, I'm not sure yet. Maybe there is like a what's that? There's like an optimal or like a greedy way in which we can build the answer. You know, because of this property, right? Because of this property, um, you can never actually have like some numbers are just not possible, right? For example, what about the number six, right? You have like one, two, three, four, five, six. Then this one, you put a zero in front of here. Can't even do seven. We can't even do seven actually. So like one, two, three, four, five, six, seven. So actually the largest possible. Oh, we can do 6661. Do six. We can do 6 6 6 6 6 6. 1 2 3 4 5 6 1 like this. We can do. What if the answer is not possible? Oh, but this is already bigger than the maximum input allowed. So like that reduces the possibilities. It makes brute force a little bit more um, attractive. Yeah, we can do this 6 6 6 6 6 6. I wonder what is the answer for this. What happens? Oh, okay, that's just the input. This is just the input. I see, I see, okay. But of course, your output can be like much larger. Mm. You can't have this input. You can't have this input, but um, your n can be anything. Right. Okay. Shit. That makes sense. Do we just brute force it? Do we just do backtracking? Even if we backtrack, let's see if we can do it in like a correct way, I guess. For this one, even if we do backtracking, when do we add like a new digit? Because you see, this is like 6 digits, but this is 7 digits. This is 7 digits. What I'm thinking of right now is like, actually, if you think about it, there's only like a few. The number of digits in a what's that, numerically balanced number, it's always like fixed or like predetermined. So if you think about it, you only have like one or two or three and so forth until like nine and so forth. Okay, you get the idea. So you have like 3 digits here. You have like 1 plus 2 digits here, so you have 3 digits. 3 digits, and you have like 4 digits. I mean, you get the idea. Here you plus 1, here you plus 1. You do another plus 1. So 4, 4, 4, 4. It's kind of like a triangle, right? If you think about it. So, 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. It's like 1 plus 2 plus 3 plus 4 all the way to 9. 1 plus 2 digits plus 3 digits plus 4 digits. So the number of possibilities are like fixed here. I guess we can like check the number of digits. For example, hmm, no, 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 no. Hmm. It's tricky, it's tricky. Oh, right, I never even thought of this case. Note that 1022 cannot be the answer because 0 appear more than 0 number of times. Interesting. So you actually can't use 0. You can't use 0. That means it actually reduces the possibility of this from 1 to 9. That means there are, but it's still 7 to 9. My initial calculation was wrong because if it was from 0 to 9, it would be 7 to the power 10. Okay. Shit. Even if it's backtracking, it's like, it's not straightforward how to do it. At least it's not straightforward for me. I was thinking, if we just iterate through all the possibilities here, like kind of like a brute force manner. So, if I write it all out, it will be like, I think it's better if I just write it out in this case. So like 1, 2, 3, 4, 5, 6, 7, 8, and then 9, right? Like this. So what I was thinking of is like, okay, given a number and whatever, right? We check, uh, is this with itself good enough? If not, oh, how about we check like, maybe I can use like a pointer. No, maybe just like a pen. Okay, yeah. So okay, we say, hey, is this itself greater than? Hmm. I guess we can handle the edge case here, like just for this case. But then we can just iterate through, right? We say, okay, for this number, uh, if I take these digits, so now I have like 1, 2, 2. I can rearrange them in any way I can, right? So what are the possible arrangements here? We have like 1, 2, 2. We have like 2, 1, 2. We have like 2, 2, 1, right? So then we say, hey, is this number greater than n? Is this number greater than n? Is this number greater than n? Hmm. I don't think we can do that yet. Then I was thinking like, oh, maybe we can combine like 1 with 3, 3, 3, and then we can move the 1 around or whatever, right? But it's a little bit complex too because how do you get the answer 22 here? How do you get the answer 22 here if you just start iterating it like that? Then you think like, oh, maybe I can just do one round of processing and check if this. It's not impossible. We do one round of processing first. Then we do the n square loop. 1, 3, 3, 3. How many different permutations are there in this number? In these numbers? Wow, permutation isn't it even worse? That's like 4 factorial, no? Yeah, I think it's 4 factorial. So it's like 1 times 2 times 3 times 4. Oh, okay, this is only true if like we treat these trees as different, but if we treat them, we can somehow group them together, that will work. Yeah, yeah, checking publications is also difficult, right, for the brute force manner. Okay, then you think like, how can I do it? How can I do it greedily? I'm still thinking along the lines of greediness. Uh, for a number of 1 digit, you can only put 1 there. For a number of 2 digits, actually you can only put 2 there. But for a number of 3 digits, you can do like 1, 2, 2, or you can do or like any combination of this, or you can do like 3, 3, 3, right? But for 4 digits, you can use the answer from like 1. You can either do 1 plus 3. Actually, that's the only one, right? For 4 at least. For 4 is like 1 plus 3. That's it. But for five you can do 4 plus 1, you can do 2 plus 3. For 6, you can do 5 plus 1, 4 plus 2. And that's it. For 7, you can do 6 plus 1. You can do 2 and 5. You can do 4 and 3. So it's always the pairs, like the last two pairs, right? Um, Interesting. I'm not sure if we can derive any sort of insight that will help us. I don't feel like there is an insight there that can help us, unfortunately. Uh, okay. What I mean to say is like for this number, we can take like the last and the first number to form this number of digits, something like that. The last two pairs. So for this, we're forming 1, but 2 can't be formed with any pairs. For 5, it will be these two pairs, and then these two pairs. For 6 is these two pairs, this one there's no pair here. 7, 6, 1, 5, 2, and 4, 3. But how does that help me? How does that help me? Next greater numerically balanced number. Gonna give myself 15 more minutes. Go. Timer. Reset timer. Play. Yeah, if after 15 minutes I can't solve this problem, I'm gonna give it up and just look at the answer. How do you solve this problem? Shit. If this was an interview, I would have already been cooked. Ah, fuck, man. Is it really just backtracking? I mean, even if backtracking is like not trivial. I mean, the answer doesn't have to be trivial, but it's like the implementation is difficult as well. But it's not like I have anything else going for me, so might as well I just do that. 7 to the power of 9, 40 million. It's definitely doable. It's definitely doable. Okay, let's go the backtracking route. Let's go the backtracking route. Not sure if they will work, but let's give it a shot. Backtracking. I'm not sure what are states we need to remember, but like maybe given a number num, if the first number that is greater than n, maybe we can say like we found the answer. So we'll have like a non-local answer. Answer is equal to 1, I guess. Or do we just try all possibilities? Yeah, okay, let's try all possibilities first. So answer equals to min of answer and min of answer and num. Will dt from 1, I guess. Return answer. We have an answer that is like infinity, right? From math, import infinity. Okay. Then we can say return. Not sure yet. Okay, so now given a number num, how do we want to do the backtracking, right? Erase all this. So given a number 1, honestly, there's like we can't really put a 2. I mean, we can put a 2, but we have to add a 2 here. And then given a number 22, what can we do? There is also nothing that we can do because yeah, we can't add a 1 here. Actually, we can actually add a 1. Actually, can add a 1. So I guess we just check all possibilities. So it's either 1 or 2, 2 or 3, 3, 3. So we roll 1. Okay. So we say if n is equals to 0, return 1. If n is equals to 1, we return 22. Then from here, we can then do the n square loop, I guess. So for num in 1, 2, 3, 4, 5. Is that how you really do it? Still a little bit confusing. In range of num plus 1 to 10. Answer is equal to infinity. The first one that we see. So how can we build it up like greedily? So 1 with 22. So this would be, the first iteration would be 1 plus 22, or rather these are the digits that we have. So we generate all permutations. I mean, if you think about it, What's the worst case? Worst case is 8 and 9. Actually, some of it is not possible. So we'll be like, let's see. Like 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, 9. Given the constraints, this is not really possible, I think. Let's see. One, 1, 2, 3, 4, 5, 6. Okay, I don't think we can do a 7 here, right? Okay, never mind, we can do a 7. Wait, what? Oh, I didn't add anything. Oh, shit. Right, okay. That means what? 1, 2, 3, 4, 5, 6, 7. Let's see again. Yeah, maybe some of these test cases, some of the cases we actually cannot reach. For example, hey shit, but only consider pairs. I only consider pairs. One plus two plus four equals 7. One, two, three, 1, 2, 3, 4, 5, 6, 7. You will always greedily put one number here like this, like this. Then what's the next arrangement? The next arrangement would be 1, 2, 4, 2, 4, 4, 4. Then would be 1. Is this really the next best arrangement? Yeah, 1, 2, 4, 4, 2, 4, 4, 1, 2, 4, 4, 4, 2, 2, 2, 2, 4, all the way until etc. And then it's like 1, 4, 2, 4, 4, 4, 2. All the way until 1, 4, then 2, 2, right? Maybe it still might be backtracking. But it is complex. So we say what? The answer has to be 1 digit or 2 digits or 3 digits or 4 digits. Then we check all possibilities. So when we backtrack from 1 digit first. df dt, this is the number of digits that we have. The number of digits that we have. Guess we can do this instead. Okay, so given digits, well, if answer equals to start equals to infinity, we can return. That means we found the answer, we can stop the backtracking. Otherwise, okay, we have 1 digit. With one digit, what are all the possibilities? Well, with one digit, with one digit, there's only one. Fuck. Uh, um, 1 is greater than n. Answer is equals to 1. If digits digits is equals to 2 digits and n, answer is equals to 22. Return. Okay, now we have 3 digits. 3 digits. We don't need this base case. Just keep it here in case. Now 3 digits. 1 plus 2 plus 3 is no go. 2 plus 3 is no go. 3. Still thinking of a loop. Still thinking of a loop. Shit. uh, actually, might not need to do this. You can just backtrack from the number of digits that we have. Okay, suppose you can somehow get some digits, right? That's quite possible. Just get a number of digits from n. Somehow get the digits. Still backtrack, then starting from that number of digits. Let's say we have 4 digits. We can try 1, 2, 2. It's not good enough. Then we try 3, 3, 3. That is too big. So we backtrack. Alright, what's the next candidate? 3, 3, 3. Okay. Okay, what if it's 3000? So do the same thing, 2, 2, not good enough. 3, 3, 3. That's too big. Okay, then we backtrack. 3, 3, 3. This is still not good enough, so we backtrack even more. 4, 4, 4, 4. It's too big. No, this is fine. Wait. Okay, so 1, 2, 2, 3, 3, 3. So this is bigger than 3000. So we set this as the answer. Then we say 3, 3, 3. This is no good, so there's no need to backtrack. 4, 4, 4. 4. Then we check if this is smaller or not. Then try 5, 5, 5, 5, so on and so forth. Actually, if this is bigger than what we already have, we don't have to continue, right? Okay. So afterwards, after we place the 1 here, where do we go? We would say, okay, can we put the 2 here, and the 1 here, and the 2 here, right? And we say 3, 3, 3. Is that good enough? Somewhere along the way, we will actually find 3, 1, 3, 3. Ah shit, the backtracking, I think it's backtracking, but it's still like, it's not straightforward how to do this. Like, how do we backtrack? How do we backtrack? How do we backtrack? Oh, Jesus. And we didn't know what we have already placed. We didn't know what we have already placed. So maybe we can say like set. So there will be empty set. This is what is placed. This is what is being used, right? So say for num in range from 1 to 10, right? If num in placed, continue. Otherwise, place.add num, place.remove num, bt digits placed. Okay, so we need to know what has been placed so far. So once we place the number, yeah, I think it's backtracking. So we definitely need placed. I'm not sure if we need to keep digits yet. Not sure. How do we do this? So initially, nothing is placed. We will place 1. Then we will backtrack. What's 9 factorial? What? Wait, 9 factorial is only 300,000. Shit, okay, I think it might be possible. In Python, there's a function called permutation. Let's see. Oh, shit. Is it called permute? Combinations? Radix? Oh, come on, dude. Okay. Wait, pretty sure Python they have like this. They have this function. Python permutation function. Permutations method. Yeah, okay. Is that really the right way to do it? Empty set. Yeah, can't see how the digits is being used. Place.add. List of place of permutations for I don't know, for x. For x in permutations, if x is greater than n, answer is equals to n. If x is greater than answer, two 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 8221. Maybe we can sort it. List sorted. No, after we permute. List. Oh my god. This is horrible. Sorted. So now if x is now a tuple. Oh Jesus. List of x. Would this work? Not sure. Oh wow, it worked. Okay. So we do like this dot join. Then we convert it into an integer. Okay, cool. Okay, so we got the candidate. So if the candidate is greater than n, then we need to check, right? Then we can check if the candidate is less than answer. Then we say we set the answer to be equals to the candidate. Otherwise we can break. Require item 0 expected stir but found int instead. X is the tuple 1. Oh, I see. Let me just see these then. One. So it's already. So maybe we don't need it to be int. Not sure. Oh, in that case, it will just be candidate, right? No, it's like 1, 2, 2. I think this is fine, but fuck. Do we really work on strings instead? Because I think we get like 1, 2, 2. That is also like kind of cancerous if you ask me. Let's see. Let's say it's like 1, 2, 3, print x. Yep, 1, 2, 3, 1, 3, 2. Okay, we might as well work with strings in that case. And then we need this. So if we work with strings, I guess we can do that. Numster. Shit. 2. No, I didn't find answer. Let's see the candidate. Place is 2. Shouldn't be 2, it should be for x in the permutation of placed. Oh, okay, shit. How should I say? Numbers. Let's go to empty list for num in place. Oh shit. A num again. Oh my god. This is getting hairy. Can't say n. Num2 in place. So that's the key. Then for frequency in range of num2, right, we say numbers dot append num2. So then our numbers is actually this one here. Oh, okay. Okay, shit. One, two, two, three, 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 three. But eventually, why is our candidates just like that? Oh, we set the answer. Shit, why is it still like that? Eh? Where are we backtracking? We didn't backtrack. DT placed. Runtime error. Oh, shit. Okay, okay. I think I should remove some of the larger test cases. Recursion limit. Wait, am I still stuck? Oh, I'm still stuck. Let's see. I see. Um, I think I'll still get stuck somewhere. Memory limit exceeded. Interesting. It doesn't even print anything for me. Come on, man. Why does it still? Why does it? Why does it keep going? Why does it keep going? Answer is not equals to infinity. Didn't I find the answer already? Answer is 122. But we can find a better answer though. Shit, yeah, we can find a better answer. I think we need to put it here. No, it's wrong. Oh shit. Hmm. It's 1 second. Oh my god, that is horrible. Runtime wise. Is it the printing that's affecting it? Nope. Still too slow, still too slow. I think I'm cooked. Ah, fuck, man. I'm so close. Oh, I think I'm close, I think I'm close. Memory limit exceeded. Shit, which part is the bottleneck? Num in range of 1 to 10. Why is the running time getting worse? Oh my god. Maybe this is better. Okay. Please don't add numbers is equals to this for key, I guess. Please for average of key we to append the key. Let me see what are numbers. We'll remove num itself. For x implementations, we'll say 10 is equals to 0, I guess. Then for holy shit. For digit in x, d plus temp plus equals d temp times equals 10. Then we have the candidate. Let's say this is the candidate. It's wrong. The hell? What's going on? Oh, okay. Now it's correct. Interesting. But still super slow. What the fuck? It's even worse now. Ah, fuck, man. It's even worse now. Even though... Is it correct though? Place is a set. Okay, there's no way in the hell this is passing, by the way. Is there a way that I can optimize this? Okay, let's see. Hey, that's a lot better by if we sort it and we do like an termination. But is it good enough? That's the question. It's really not that much better, to be honest. Nope, it's not good enough. Just not good enough. Oh, I mean it works, but that's because of this property. I'm pretty sure it fails for like everything else. Or like I just got lucky. What if I do this? Yeah. Please. Please. Actually, this might work. But do the permutations, do they do it like in order? Do they do it in order? I think they do. Let's try the harder cases. 1, 2, 3, 4, 5, 6. That's the maximum input. Whatever. Do it like this. Maybe another one. Whoa, okay. Maybe this is it. Maybe this is it. Off the fucking fan. Fuck. Wait, what? Oh, that's because of the early termination. We found a better answer later down the road. But if I remove that, I'm afraid it wouldn't pass the early termination part. Because now we are literally checking every fucking number. Yep. So I just got fucking lucky. Hmm. I'm thinking about going from the end instead. Going from the end instead. What do I mean by that? It's like we go from 9 to 8 to 7 to 6 instead of like from 1 to 10, right? We go in the reverse order. So we'll add 3 2 first and we'll find the answer. Oh, does that work? I feel like it doesn't work. Because this saying is, okay, we do 1 2 3. Yeah. Hmm. I think we have to greedily backtrack, right? I think we're almost there. 4144 41444. We want to somehow reach 2 and 3 first. But the only way to reach 2 and 3 is if we go from the back. But then you have another set of problem, right? This time around is the opposite problem. Because now you're like, so we need to somehow do a check somehow. Somehow do a check somehow. Wow, thanks. Thanks a lot. Uh, I guess it's kind of abusive, but like, it's not really infinity per se, because the maximum input is, this is the maximum answer. That's a little bit of a cheat code. Hmm? How come we never find the answer? Ah, backtrack. Oh, okay, how do we stop? No, it wouldn't work, would it? Yeah, I don't think it will work. It wouldn't work because we'll find the largest answer first, right? Then they say, oh, we found the largest answer, we will just break it. Hmm. This will break it. This will this will break it. So 1, 2, 3, 4. 1 and 2, 3, 4, 1, 2, 3. Oh my god. Okay, I give up. I give up. Uh, I'm, I think it's backtracking. Yeah. Huh? Okay, come on. Oh my god, looking at this now, I feel so fucking stupid. Yep. Oh, this is a linear. Is it really linear? Okay. Wait, what? That's so dumb. Yeah, exactly. Shit. Yeah. Um. Fuck. The backtrack. Yeah, this is the solution. Well, it sucks. It is what it is. By the way, guys, thanks for watching. I hope you have a great one. Bye.